No worries, we will support you.
Let's check. And it stopped working. Okay. So first of all, hi, I'm Robert Pająk. You can find me as Pelaret on GitHub. I sometimes recreating issues and pull requests in open source stuff, usually in OpenTelemetry. I work here at Splunk, which is a Cisco company. So basically, I'm very grateful that Splunk pays me for doing open source. And yeah, I'm an OpenTelemetry Go maintainer, it's specification sponsor. And regarding this talk, the most important thing is that I'm contributing to OpenTelemetry Logs. And basically, I started prototyping and designing OpenTelemetry Go Logs November 2023. So first of all, I'm not an English speaker, but whatever here is not clear, don't blame my English. It means that I'm not prepared at all, and I have no fucking idea what I'm talking about.
Oh, native English, shouldn't be that bad.
So let me say what this presentation will be about. First, it will be about OpenTelemetry logs. So basically, just a context, so you know what logs are in OpenTelemetry, to have some high-level understanding. And the second point will be about the designing process of logs API in OpenTelemetry Go. So just a 1-minute recap about OpenTelemetry. Please raise your hands who know what OpenTelemetry is. All right, yes? Everyone, to be honest, raised their hand. So without going quickly, it's a basically framework or standard approach for processing and exporting telemetry data. So it's basically about instrumenting your software application, preparing your data and sending it somewhere, whatever it is. So, and there are 4 signals right now: traces, metrics, logs, which we will be talking about in depth, and development or experimental profiles. So basically, the key is that it's a one standard, one unified approach. So you have this also kind of signals that are correlated. They are not separate pillars, but they have. So for instance, when you have a log, you can have a trace context within a log. When you have metrics, you can have exemplars connected with traces. So the key thing is that it's one standard, and also these things are being correlated. Okay. But let's talk about the data model of OpenTelemetry logs. So the key thing is that OpenTelemetry logs are not just like a plain one line of text. This is not just a line, an UTF-8, basically encoded stream on a standard output. Basically, the data model says that it's a structure. It contains timestamps. So it has a timestamp when something occurred and when it was observed. So, the second thing, is it working? The second thing is trace correlation context. So this is the thing which makes your correlation magic happening. There is also severity, but it's not only a level. It's not only a textual representation. It's also a number. So it allows you to having some thresholds. There is a structured body. So for logs, it's usually just a log message. There are also metadata, which can give you more context about the log record. And these attributes can also be coming from semantic conventions. So OpenTelemetry has also standards about naming some kind of this metadata attributes, so that when there are people who tell. So there's a standard, for example, for an exception message, exception type. So when you have a lot of applications, each of them should use the same names to capture the same semantics. There is also a resource which tells you what software has emitted this log record, and instrumentation scope, which should tell you what piece of code has emitted this log record. So it's not just a string of timestamps. And these are logs that carry some more context. Also, the important thing is that logs in OpenTelemetry are structured logs. So the attributes and body can have complex values. So these values can be a primitive, but it can be also an array of any value. And when I say array of any value, it means that the first element of the array can be an integer, the second can be a string, the third one can be an array of any value, etc. So you can imagine, and also it can be a map of string to any value, so you can represent basically any structure. At last, it can be also a byte array, so something which you cannot see in JSON. And an empty value, because everyone loves nulls, etc. But you can approximate to something like a bison. So here's an example. Right now, everyone uses GenAI. I have created this presentation using GenAI because otherwise I wouldn't be able to create a presentation which looks like that in 4 hours. It will be impossible. So here's an example how complex attributes could look like in OpenTelemetry. So you can see that we have a GenAI prompt which has basically an array of maps to strings. So it's basically that OpenTelemetry allows creating rich, structured, and meaningful data. Okay, and now the question is how you can emit logs in OpenTelemetry. So I would say that there are 3 ways how you can do it. First is you can use a file stream capture. So you can have a std out and you have some collector and, for example, scrape your data for some files and basically put it further. This kind of logs can sometimes miss this kind of context correlation with traces, depending on how it is set up. The second option is using log bridges. So OpenTelemetry has the concept of automatic instrumentation and instrumentation libraries. So basically, you can have bridges for log4j, for Java, or slog when we are talking about OpenTelemetry Go, which basically means that you capture that your output of your logging library is the OpenTelemetry, basically. So basically, it translates the model of logs in your of some logging library to the OpenTelemetry data model. That's why it's called a bridge. And the third option is using the logs API directly. So basically, not using any slog, it's just using the logs API directly. But why do we need a logs API? Why would not use just for example, slog? So the thing is that the logging bridges basically needs this kind of API anyway, because we need a way basically to translate one to another. So in order to be able to translate, for example, slog or logras or logar or any other logging library to some other model, we need a destination basically package and model. So this is the first reason why we need such API anyway. The second is that when you have some instrumentation, when you have some libraries, for instance, MongoDB provider or whatever, and you want to instrument it with OpenTelemetry, you do not want to have, you do not want this instrumentation to depend on slog, logar, or other library, because then you would require, for example, your application to use some concrete bridge, and it could also basically make a mess with your logging solution. So basically, it's critical to avoid coupling to these logging libraries. And the third reason, I think this is the last one, if I remember correctly, is having this first-class logging experience so you can use it directly. And is it written here why? Yeah, the reason is that, so for instance, in slog, you do not have a concept of an event record. In OpenTelemetry, we have a separate log record and event record. An event record is basically an event which has the same structure for each record. And so if you have an event name, you assume that each occurrence of this record will have the same structure. So this is something which doesn't exist, for example, in slog. You could make some magic, play with additional attributes, but this gives you the first-class logging experience. And the third reason is that if you use the logging, the OpenTelemetry APIs, you can reuse existing codes. For example, reuse existing attributes that you use for your spans, also for logs. Okay, so this was this preface, and now I want to tell you about how the designing process looked like. So this talk will be more about the process of designing the API than basically even I would go very deep specific into Go, but I will do as well. But the main purpose of this talk is about basically giving a use case how a design process could look like. So this will be with design decisions, trade-offs, and lessons learned. So the design process. So this was the essential part of making OpenTelemetry Logs API happening. And we found it. So in OpenTelemetry Go, we decided that we need to come up with a process, because when we were creating trace APIs and metrics APIs, we found out that we are basically backscattering, going in circles back and forth. We also saw that we missed a lot of performance improvements that were later we were not able to fix. We introduced heap allocations which were caused by the API themselves. So people need to make some object pools, etc. In order to not make a lot of heap allocations. So we wanted to make sure that we have some process to mitigate future problems. So the thing about this, so how the design process for logs look like? First of all, we had a previous prototype. When OpenTelemetry Logs was created and added to the specification, one of the things which was added, there was a Go prototype. But it wasn't a prototype that was added to the OpenTelemetry Go repo. It was just a prototype for the sake of the specification as a proof of concept. But still, it was a working code. The second part of the design process, which was very important, is that we needed to agree what are our constraints and what values we see as the most important. So if we have two designs, we need to have a way to say which one is better. And we needed to make it like this. The distinction cannot be subjective. It had to be objective. For example, this is faster, we prefer faster. So basically, we value three things which are the most important. First is specification compliance with OpenTelemetry. So we make sure that people coming in different languages has the same user experience. Second was performance. And third was user-friendliness. And this is like the priority, and these are the priorities for us. So specification compliance is the first, second is performance, third is user-friendliness. And we also thought that in order to evaluate, we need to have a working prototype in benchmarks. Because if you do not basically writing something on paper doesn't, you have no proof that something is better or worse. We wanted to make sure, we wanted to be really sure that and validate our designs. So together with the design, we are creating prototype which was checking if this works with tests and with benchmarks. So basically we had a large pull request which had thousands of code, which was used as a reference. So it was not something that we were supposed to merge because there were no documentation for this stuff, but it was for the purpose of the good design. And last, we also see that we need a design document, and we decided that we do not want to go with Google Docs or something like that. We decided to have a design document in Markdown that so that we can comment, we can refine it, it can be living documentation. And we also saw that it is important to not only describe the current design, but also the rejected alternatives and our decisions, trade-offs, because these are usually the things which come up very frequently that people ask, why haven't you not designed this way? Why have you designed that? So basically, this design document is also a way to capture our decisions. Constraint and values. I think I saw it before. So specification compliance is a must for us. High performance is critical, and user friendliness is important. So the prototype development, long living graph PR. So I'm just repeating myself. So benchmarks are inspired by S-log. So basically, Amster Jonathan gave a great talk and also shared a lot about his experience when he was designing S-log. So basically, we try to steal as much as possible from his experience to not reinvent the wheel. So basically, the performance testing was taken from their approach, and every change we did in the design was validated. So when we had a one PR, this long living. So we created micro PRs against this one to check if, for example, if a change will, for example, if improve the performance or not. And yeah, test, don't trust. It applies to this presentation as well. Don't trust me. So this is there is a tool called BenchStat. So if you run benchmarks using the Go test bench, and if you capture them to a text files, you can then compare two benchmarks using a tool called BenchStat. So it is basically a tool created by the Go team, and it's perfect for comparing performance. So we basically were when we were talking about logging, we looked at two things. One is the CPU performance, and second is the memory allocations. And to be honest, we were more worried about the allocations, because this is something when the garbage collection has problems, you allocate too many objects. In a long-living application, you can have more problems than having a static amount of just, it takes a few milliseconds longer. Basically, this is a predictable thing. This can be unpredictable in long run. You can see our design document here. If you go to, so you can click it. My cursor is still here. Yeah. So you can find all our constraints, trade-offs, rejected alternatives, and implementation details. So if you're more interested into some, Go specific thing, you can go into the design, look at the pull requests, etc. Yes. I see someone is making photos, but yeah, later we will also have the hyperlink for this whole presentation. The thing which I want to discuss during this talk, as an example, is how we were going through the design of logger emit. So basically, the emitting a log record is the most critical part of logs API. So this is the place that is the most performance critical, because when you're having a logging library, the thing which you do the most often is just emit a log record. So this is the thing which should be basically should be as performant as possible. And yeah, so we had a lot of design challenges, and they are also same as for slog and other libraries. We also have other challenges, such as specification compliance. I just want to show how the initial prototype looked like. So from what we started. So initially, the logger interface looked like this. It was basically, yes.
Sorry, just one question. Is it?
You want a mic? Give me.
No. Is it Go routine safe? Is it thread safe? I'm not sure how to.
Concurrent safe.
Yes. Is it? Maybe. Sorry. Just the question. Maybe it's later on the slide. So if I'm asking this question too early, I apologize. But is it thread safety in the specification or not? Or
yes.
Okay. Thank you.
Yeah, concurrency safety is one of the most important things for the specification. Even if it was not, we will still worry about it.
Yes.
So this kind of API is basically following the existing patterns of tracing and metrics API. And we knew from our previous experience, so this is basically an example. So this is a familiar pattern. But we knew that this kind of variadic argument, when this is an interface, always causes heap allocations. And basically, we decided that we do not want to follow these patterns for emitting the logs. So now we see how it looks like currently. So basically, we have right now a simpler call. So right now, instead of having here this kind of options, we just have a record, which is a struct. So it is still similar to other OpenTelemetry APIs, but most importantly, it's similar to Go logging patterns. So if you see the slog sync interface, I think it's almost one-to-one, basically, if you look at it. But the thing is that if you have this record, it's a single parameter that is more efficient, but it's also easier to extend and keep it backwards compatible. And you can also I think it will be next slide, but the thing is that you can encapsulate a lot of complexities into the struct, and the options is not usually possible because then you need to process the options, etc. And here you can encapsulate everything in the record. So if you do something in the record, you can also reuse the record. With options, reusability is not that easy. Yes, so basically how it works, so one of the optimizations that we did, which is basically is stolen from slog, is that instead of having a slice of attributes, there's an array, because arrays can be stack allocated because we know what's a size. So basically from the slog analysis, 99% of use cases use only 5 logging attributes. So we have an array of 5 attributes as an array, and if there's more attributes, they are just added to a slice later. And basically, because we have structure, we have methods, we could encapsulate those things inside methods. So we have add attributes method, which adds basically that attributes first to the array and then later to the slice. And you have walk attributes method, which allows you iterating through the attributes. And basically, this allows having 0 applications. It makes it possible. Okay, but the thing is that right now it looks simple, but getting there was very hard. And here I want to share how much alternatives we have rejected for this one single signature, which people were asking for. One of the things, some people said that they wanted to have this record as interface. So different implementation had different, for example, implementations of adding attributes. So one can, for example, have a backing array for 10, another for 5. But the thing is that, for instance, having an interface in the struct causes additional, I don't remember right now the Go term, but it causes an additional layer of indirection. And from the Go calling experience is simply slower. In theory, it could maybe also cause a heap allocation, but I think the escape analysis was pretty good here, and usually it didn't have it was possible to have 0 allocation as well, but it was always slower from the CPU perspective. The second, which was previously from the prototype, is using options as parameter. So even though we knew it upfront, some people still didn't believe it. We needed to have another PR that proved that having options as parameter caused problems. Record as pointer. So I don't remember the interface had record right now as struct, but there was also a proposal to have as a pointer to struct. And the thing is that even the Go team says that they advise you, and basically slog did the same. They prefer using a struct because there's a higher probability that it will be stack allocated and not allocated on the heap. And even if the current implementation of Go makes a stack allocation, it doesn't mean that future implementation of Go will not keep it on the heap. So having it as struct gives you higher chances to have it had the record stored as on the stack. Logger with attributes. So another idea was to basically come up with something that you pre-allocate some attributes before emitting a record. I do not remember right now the exact reasons, but it also didn't help with. It also didn't help somehow. Just trust me, it's in the notes. There was also an idea that maybe you should simply put the attributes at slice and basically put the effort of dealing with the just ask the application developers, the callers, to create the pools on attributes by themselves. But using pools also causes heap allocations. It's just long living these allocations, and it is a very painful way to use your APIs if you know that you need to create your own pools of attributes. It's very buggy as well. One of the things about the structure and logging, I don't remember if you recall. So there was you can create those structured complex attributes and body. One of the proposals was to just accept any as an attribute value. But the thing is that it's bloody inefficient because you will need to use reflection. It's basically an interface, so it's an indirect call. So basically, we have an log value type, which basically is like kind of like an union, I would say. So we have a dedicated type, which basically says what kind of it is, and basically it improves the performance a lot. And slog has the same. There was also an idea of encapsulating the severity number and text into a separate structure, but the problem is it will not be specification compliant, because what will reuse attribute package. So OpenTelemetry Go has also a separate package called attribute. And the thing is that we could not reuse it because log attributes are a superset of log attribute of standard attributes. So you cannot have these maps using the OpenTelemetry attribute package. Mixed receiver types. So some people claim that it will be better to have, so when you have the receiver type of the method, you can have a pointer or a value. So one of the proposals was just to add the value type only when it's read-only, and pointer when you make a change. For example, you add attributes. And the thing is that we made a lot of benchmarks and it didn't have any change. So we decided to have everything as pointers for basically to make it easier for the reader and the future development. We decided to not add any other helper methods to the logger because any bigger API, it's harder to maintain. So if people want to have helper methods, they're free to make their own packages that are encapsulating. And there are also separate proposals to rename key value to add. And there's also, I think this is wrong. I think there's also an idea to reuse simply slog. But yeah, it's a no-go for us because we need our own API. So you see there are two rejected proposals just to go to this one line of method. So basically getting this one line took like a year or something like that. So we started this like in November 2023. Yeah, and each of these rejected was considered. And the evolution continues. We are still not there yet. So the thing is that the specification changes, and it changes in a way that will make the API very unwelcome for future users. So one of the change which is going to specification, which also come up from us, but after another languages were implementing it, they said the same feedback, is that we want to add these complex values to all signals, because people also, when they're having spans, sometimes they're using very complex systems. They also want to have the ability to have these complex structures in other signals, not only for logs. And because of that, if we extend the attribute package and add this map and array value, heterogeneous array values, you will be able to not have this log value type, which we added. We can just add it to attribute package, reuse the same types across all signals. Yeah, and basically I'm going to the end. So I just want to say, and so this was the journey, just an example, but the key things like lessons learned are that without these clear priorities, you will not be able to go further. Probably you will have stabilized the API before we learned that we make a lot of mistakes. We knew that we need to test everything and have some backup, which is quantitative and it's not subjective. And without having this documented and having the design doc and everything transparent in GitHub, you just go back and forth in circles. And also, with having this documented, it also allows us to extend it in the future. So we can double check the design doc and add future enhancements. Yeah, and always when you design some very APIs which are reused in a lot of places in your code base, it doesn't need to be open source. Very carefully think about the evolution of the API. So if you not need to refactor your whole code base, if you need to make a change. I have some extras. These are some resources which help me a lot from the technical perspective. So there's a very good talk about understanding allocations, which is from some GafferCon. Next is Jonathan Amsterdam is the main designer of SLog. There's a great talk about how they designed Go Logs. And the thing is that this talk is not only about logging, it's about basically any performance-oriented design in Go. There's a cool website called Go. I think it is Go Performance Guidelines or something like that. And this is just one of the best parts is the common Go patterns. It describes things like using escape analysis, using pull allocations. It describes how basically the design before IO writer, IO reader, and buffering and stuff like that. It's a great resource. And the last one are the official Go diagnostics and GC guide by the Go team, which also is evolving and has a lot of good resources about Go performance. I'm done with talking. Do you have any questions? Are you sleeping?
No, yet.
No.